Hi, welcome back to Moose and Chemistry. This is Nuclear Chemistry Neptunium Decay Series 1. So, we're going to go from Neptunium to thallium. Alright? But we're going to go through this pathway here to get there. So now, if you see this A, that means alpha decay / emissions. A 4He nucleus, or 4,2 alpha, which is called an alpha particle, is removed from the parent atom to change the element into a different element. We're going to use this equation here. AZX yields A minus 4, Z minus 2Y, plus our alpha particle, right? A right here represents the atomic mass unit, or the AMU, which is the number of protons and neutrons in the nucleus of an atom. Z represents the atomic number, which is the number of protons. Y represents the element it's being changed into, and of course this is your alpha particle. Alright, if you see a B, that means you're undergoing beta decay. Now beta decay, or emission, is 0 minus 1 E, or 0 minus 1 beta. A neutron is converted into a proton, changing the element into another element and releasing a beta particle. We're going to use this equation here. AZX yields AZ plus 1 Y plus our beta particle. That's our beta particle. Z represents, again, the atomic number, which is the number of protons in the nucleus of the atom. And A represents the atomic mass unit, or AMU, which is the number of protons and neutrons in the nucleus of an atom. All right, let's go ahead and let's take the path. So we start off with Neptunium 237, and we undergo alpha decay, and we get protactinium 233. Protactinium then undergoes beta decay and gives me uranium 233. Now, notice that the AMU didn't change because in beta decay we turn a neutron into a proton. Alright, so then uranium undergoes alpha decay and becomes thorium 229. Alright, thorium 229 undergoes alpha decay and becomes radium 225. Radium 225 undergoes beta decay and becomes actinium 225. Actinium 225 undergoes alpha decay and then becomes francium 221. Francium 221 undergoes alpha decay again and becomes Astatine 217. Astatine 217 undergoes alpha decay right here, becomes bismuth 213. Bismuth 213 undergoes alpha decay and becomes thallium 209. Thallium 209 undergoes beta decay, it becomes lead 209. Now, lead 209 is still slightly radioactive, so it undergoes beta decay again, and it becomes bismuth 209. And bismuth 209 finally goes under alpha decay again. It becomes thallium 205, which is stable. All right, so let's look at the table here. All right, element 237 Neptunium has a half-life of 2.1 times 10 to the 6 years. That's a pretty long time. Protactinium 233 has a half-life of 27 days. Uranium 233 has a half-life of 159,200 years. Okay, pretty good chunk of time. Thorium 229 has a half-life of 7,340 years. Radium 225 has a half-life of 15 days. Then element it's hard to say sometimes. AC, I think it's actinium. Yes, actinium has a half-life of 10 days. Francium 221 has a half-life of 5 minutes. Astatine has a half-life of 207. Astatine 217 has a half-life of 32.3 seconds. Bismuth 213 has a half-life of 46 minutes. Thallium 209 has a half-life of 2.2 minutes. Lead has a 209 has a half-life of 3.25 minutes. Bismuth 209 has a very long half-life of 1.19 times 10 to the 19 years. And then finally, it gets down to thallium 205, which is stable, or what I call the end game, which means it doesn't decay any further. Well, guys, you be snarly, and we'll see you back here at Moosing Chemistry.